GeopByte.
Welcome to GeopByte. Hi students, in the previous video we have discussed exercise number 1.1 from first to fourth question. In this video we are going to discuss exercise number 1.1 from 5th question to 11th question. Now let us see exercise number 1.1 fifth question. Name the property under multiplication used in each of the following. First bit, minus 4 by 5 into 1 is equal to 1 into minus 4 by 5 equal to minus 4 by 5. Second bit, minus 13 by 17 into minus 2 by 7 equal to minus 2 by 7 into minus 13 by 7. Third bit, minus 19 by 29 into 29 by minus 19 is equal to 1. Now, let us find the property of each of the following. Let us see for first bit. Here we can observe that a into 1 is equal to 1 into a equal to a. So, it is in the form of multiplicative identity. So, existence of multiplicative identity is given as a into 1 equal to 1 into a equal to a. So, it is in the form of multiplicative identity. Next, second bit. Here we observe that a into b is equal to b into a. So, it is in the form of a into b equal to b into a. So, it is the commutative property of multiplication. Let us write. Commutative property of multiplication. Next, let us see the third bit. Here we see that it is in the form of a by b into c by d is equal to 1. So, it is in the form of multiplicative inverse. So, multiplicative inverse is given as a by b into c by d is equal to 1. So, it is in the form of multiplicative inverse. So, existence of multiplicative inverse. Now, let us see the sixth question. Multiply 6 by 13 by the reciprocal of minus 7 by 16. Let us find the solution for the given question. So here we need to multiply 6 by 13 with the reciprocal of minus 7 by 16. So let us write it as 6 by 13 into reciprocal of minus 7 by 16, that equal to 6 by 13 into reciprocal of minus 7 by 16. So, the reciprocal of minus 7 by 16 is minus 16 by 7. So, minus 16 by 7, that equal to 6 into minus 16 is minus 96. So, minus 96 by 13 into 7. 13 sevens are 91. So, we got the answer minus 96 by 91. Now, let us see the 7th question. Tell what property allows you to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Let us find the answer. So here we need to find the property. Here we can observe that it is in the form of A into B into C is A into B into C. So associative property is given as A into B into C is equal to A into B into C. Let us write. Associative property under multiplication is given as A into B into C is equal to A into B into C. So, it is in the form of A into B into C equal to A into B into C. So, associative property of multiplication over rational numbers allows us to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Associative property of multiplication over rational numbers allows us to compute 1 by 3 into 6 into 4 by 3 as 1 by 3 into 6 into 4 by 3. Let us see the 8th question. Is 8 by 9 the multiplicative inverse of minus 1 by 8? Why or why not? Let us find the answer. Is 8 by 9 the multiplicative inverse of minus 1 by 8? No. 8 by 9 is not the multiplicative inverse of minus 1, 1 by 8, because 8 by 9 into minus 1, 1 by 8 is equal to 8 by 9 into, here 8 ones are 8. 8 plus 1 is 9. So here minus remains same and 9 by 8. This is equal to minus 1. Actually, this should be equal to 1. So here we got the minus 1. So minus 1 is not equal to 1. Therefore, 8 by 9 is not the multiplicative inverse of minus 1, 1 by 8. Now, let us see the ninth question. Is 0.3 the multiplicative inverse of 3, 1 by 3? Why or why not? Let us find the answer. Is 0.3 the multiplicative inverse of 3, 1 by 3? Yes. Yes. 0.3 is the multiplicative inverse of 3, 1 by 3, because here 0.3 into 3, 1 by 3 is equal to, here 0.3 can also be written as 3 by 10. So 3 by 10 into, here 3 into 3 is 9. 9 plus 1, 10. So 10 by 3. This is equal to 1. So we know that 1 is the multiplicative identity. So 0.3 is the multiplicative inverse of 3, 1 by 3. Now let us see the 10th question. Write first bit. The rational number that does not have a reciprocal. Second bit. The rational numbers that are equal to their reciprocals. Third bit. The rational number that is equal to its negative. Let us find the answers. First of all, let us find for the first bit. They gave that the rational number that does not have a reciprocal. So we know that when a number or any rational number multiplied by 0 doesn't give answer as 1, because anything multiplied with 0 is 0. So the rational number zero does not have the reciprocal. Therefore, 0 has no reciprocal. Next, second bit. Write the rational numbers that are equal to their reciprocals. So we know that the reciprocal of 1 is 1 and the reciprocal of minus 1 is also 1. So minus 1 and 1 are the only numbers which are having the same reciprocals. That is, the rational numbers minus 1 and 1 are equal to their own reciprocals. So, the rational numbers minus 1 and 1 are equal to their own reciprocals. Next, write the rational number that is equal to its negative. So, we know that 0 is either a positive integer or a negative integer. So, 0 is the number that is equal to its negative. The rational number zero is equal to its negative. Therefore, the rational number 0 is equal to its negative. Now, let us see 11th question. Fill in the blanks. First one, 0 has dash reciprocal. We know that 0 have no reciprocal. So, let us write no. 0 has no reciprocal because anything multiplied by 0 gives 0 but not 1. So, 0 has no reciprocal. Second one, the numbers dash and dash are their own reciprocals. We know that 1 and minus 1 are the only numbers which have their own reciprocals. That is, the reciprocal of 1 is 1 and the reciprocal of minus 1 is also minus 1. So, 1 minus 1. The numbers 1 and minus 1 are their own reciprocals. Next, third one. The reciprocal of minus 5 is minus 1 by 5. Therefore, the reciprocal of minus 5 is minus 1 by 5. Next, fourth one. Reciprocal of 1 by x, where x is not equal to 0, is x. Therefore, the reciprocal of 1 by x, where x is also not equal to 0, is x. Next one. The product of two rational numbers is always a. We know that the product of any two rational numbers is always a rational number. So let us write the answer. Therefore, the product of two rational numbers is always a rational number. For example, if we take the numbers minus 2 and 3, if we multiply minus 2 and 3, we will get minus 6. So, in this example, minus 2 and 3 are the rational numbers and the product of minus 2 and 3 is minus 6. Minus 6 is also a rational number. So, therefore, the product of two rational numbers is always a rational number. Next, sixth one. The reciprocal of a positive rational number is. So, we know that reciprocal of any positive rational number is always positive. Let us write. Therefore, the reciprocal of a positive rational number is positive. The remaining topics will be covered in the next video. You are welcome to contact us on Telegram to clarify your doubts regarding these topics. Check out the link given in the description. Thank you for watching. Please do like, share, comment and subscribe to GeopByte.
GeopByte.